naming organic compounds. So I'm going to just give us, let's say, a last example. Let's look at this. Let's look at this example now. CH2, CH2, CH3. So we have this as C and then CH2. Let me make it clearer. So we have this. Okay. So we have this. We got it now as CH3, CH2, C, CH2, CH2, CH3, C, CH2, CH2, CH3, CH2, CH3. Now, dear students, I leave you with the challenge of trying to identify where our parent chain will be. Looking at the question, the hydrocarbon given to us, we are required to look carefully and identify the longest continuous chain, which will be our parent chain. If we are to go with the straight chain, we are going to have 6 carbon atoms. If we are to go with the straight chain, that is to say, if we are to go straight this way, we are going to have 6 carbon atoms. But are we sure that that chain is the longest continuous chain? That is the question. Is it the longest continuous chain? Let us look at, if another student chooses to go this way, another student may choose to go this way, like this way, this way, this. So this is also a way. 1, 2, 3, 1, 2, 3. It is also going to give us 6 chains. Is it the longest chain? So whichever way you choose to go, please be careful and make sure that you are taking the right chain. Now, another student may choose to go this way, like this, like this, like this way, like that. You can see. So we have 1, 2, 3, 4, 5, 6. So all these are different ways one may choose to, but you ought to be very careful to looking at the longest chain. So in all the chains we've counted so far, we have counted 6 up, 6 down, and now we have seen another one, 1, 2, 3, 4, 5, 6, 7. Now we are counting 7. So you can see, if I had gone straight, I would only be counting 6 carbon atoms. But if I count this way now, I will be getting 7 carbon atoms. You see? So this is one way also. So you ought to be very careful, very, very careful in taking your longest continuous chain. And we ought to also ask ourselves, could this be the longest chain? Could this be the longest chain? You never can tell. Let us take a look at another chain. Let us take a look at, if we then go this way, let's say we choose to go like this. We can have it like this. Okay, let's say we have it like this. Okay, we have this. Let's take away this. So we have a chain that goes this way up. Okay. Okay, we got it like this now. So we have a chain that goes like this. If we choose to take our chain this way, and that way, and this way, that way, and that way, and then we have this way. Let's look at this. Let's take a look at this. Yeah. So let's say we choose our chain to go this way. So we have so if we choose our chain to go this way, we can see now we're having 1, 2, 3, 4, 5, 6, 7, 8. So we can see we are having 8 continuous chain as the longest chain. We are having 8 continuous chain as the longest chain. That's what we're having. We're having 8 continuous chain as the longest chain. So it automatically proves that this is a side chain and this also will become a side chain. So we now ought to take our numbering. Do we go from down or do we come from this place? Up is, let's say, if we are to straighten it up, it's going to be up will be right and left, down will be left. So do we come from the top or from the bottom? So going from here, we have, if we are to begin from the bottom, this will be carbon 1. This is carbon 2, 3. This will be carbon 4. And this will be carbon 5. So it means the two compounds, it means our two compounds will automatically be at carbon 4 and carbon 5. There should be a 3 here. They will be at carbon 4 and carbon 5. Carbon 4 and carbon 5. So this will be 6, 7, and 8. Then if we choose to number from the top, if we choose our numbering from the top, this will be carbon 1. It implies that this will be carbon 1. This will be carbon 2. This will be carbon 3. And we have, this will be carbon 4. And this will be carbon 5. So whether from the top or from the bottom, they will both be at carbon 4 and 5 respectively. So we can see that is how the structure looks like. So let us see how to draw that structure again and get to understand what we have just done. So we have, still leaving the structure there, we have it as CH3. Let's get to understand CH2, C, and then we have CH2 and CH3. So here we have CH2, CH2, CH3. And here we have CH2. We further have another CH2. And then we have CH3. There you go. and of course we have H. So this is how our structure look like, and we have just said that our parent chain is like that, like this, like that. It goes like this, like this, like this, that, that, and this. So that's the parent chain. So that is what we saw there. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is the longest continuous chain. So if we are to go with that, we have our side chains now. This is side chain, and this is side chain. So this is clearer now. So our side chains are both at carbon 4 and carbon 5. And these side chains are the same. They are both ethyl. This is ethyl. This is ethyl. And the other also is ethyl. So what will it be? This compound is simply 4,5-diethyl octane. 4,5-diethyl octane. And that is what it is. It's as simple as ABC. The only challenge is you may be given such kind of complicated structure, and your challenge will be identifying the parent chain. So with all these examples, dear students, you are now equipped for any kind of nomenclature. And we want to believe that you are now very strong. So having seen that, let us not just leave you that way. You are going to be challenged. Now let me challenge you with the following structures. So you can take your time, sit back, relax, and attempt the following structures. Give the names, the IUPAC names of these following structures. The first one, these are for your consumption. So for you, this is your STS. This is, you have a structure like this. This is question 1. Question 2. You are to give the IUPAC names of these compounds. And without hesitation, please kindly post your answer to the platform. Kindly send us your answer as quick as possible. So we have chlorine and fluorine. As number 4, I'm going to give us number 5 here. Number 5 is CH3, CH, CH2, CH, CH2, CH3, CH, CH2, CH3, CH3, and CH3. That's number 5. Number 6, we have CH3, CH2, CH, CH3, CH, CH2, CH3, CH2, CH3. As for number 6, okay. Number 7, for number 7 we have CH3, CH, CH3, CH, chlorine, CH2, CH3. And then we have the last question for the day, CH3, C, CH3, CH3, CH2, CH2, CH, double bond, CH2. So you have a bonus of +2 already. So when you get the correct 8 answers, you're going to be having 10 over 10 multiplied by 10. So that gives you 100. So you're having a bonus of 2 already. So you are to answer all 8 questions correctly and then kindly send it across to us for vetting. Now, having seen that, we have come to the end of all rules that governs the IUPAC nomenclature. So I want to believe, dear students, that you are now so much loaded with the idea of how to name IUPAC compounds. So having seen that, let us proceed to the next subtopic, which is isomerism.